Good afternoon. So today what we will do is we will discuss equivalent resistance, and we will find equivalent resistance of circuits that offer symmetry. So आज हम कुछ न्यूमेरिकल करेंगे जहाँ पे equivalent resistance निकालना होगा और हम सर्किट की जो सिमेट्री है कि सर्किट देखने में सिमेट्रिकल है। जैसे कि आप मेरा फेस देख रहे हैं, तो मेरा फेस अगर यहाँ से आप लाइन खींचें तो दोनों साइड कुछ हद तक सिमेट्रिकल है, लेकिन जिन सर्किट्स की हम बात कर रहे हैं वो परफेक्टली आइडेंटिकल होंगे और एक टाइप ऑफ सिमेट्री ऑफर करेंगे। और सिमेट्री ऑफ सर्किट देख के आप उसका एडवांटेज ले सकते हैं और आप उसका इक्विवेलेंट रेजिस्टेंस और अलग पोटेंशियल करंट वगैरह निकाल सकते हैं। सो द फैक्ट दैट सर्किट ऑफर्स अ लेवल ऑफ सिमेट्री is a big advantage, and what we will do in the upcoming numerical is to use this concept of symmetry to take advantage of and solve the problem. Normally, questions on symmetry, which are advanced problems, and one of them is in NCERT, which is the problem of cube, is an advanced concept and is taught in electrical engineering. But NCERT has introduced some cube, where there is some amount of symmetry, and if they have solved the problem. So what we will do now is we will exploit the symmetrical feature of the circuit, and we will find the equivalent resistance. So this is very similar to what you would see in NCERT. And so I'll try to make it as simple as possible. These types of questions are long, and but there can be multiple shades, right? So the one which is related to cube is pretty complicated. It takes time, but it's very JEE type of problem. It's an advanced problem. You can expect problems pertaining to symmetry in NEET examination, but the complexity of the circuit and associated calculations would be relatively easy in NEET examination. But JEE Mains can be a bit tricky, longish, and cumbersome, and JEE Advanced obviously will be more cumbersome. So when you solve these problems, using and exploiting the symmetry of the circuit, just look for where is the symmetry and exploit that feature. So just see how I do it, and maybe it'll give you a good perspective on how to use symmetry to your advantage and find equivalent resistance and other parameters of the circuit. So thank you very much for your time, and just wait for this video which will follow this conceptual discussion you just had. And I just wanted to give you a big picture of where this numerical stands and how do you approach it. So the keyword is symmetry of circuit, and let's see how do we exploit that to our advantage. Thank you. So this is a cube which is shown to you, and the whole if you see, the purpose is to understand the symmetrical nature of the circuit and exploit it. So the point A is at 0 volts, and the point B is at 1 volt. So when the current starts, for example, this is a current which is I, and so when the current reaches the point A, okay, let's see the point A. It has 3 routes, okay, and all the routes are identical. So this is I by 3 by symmetry. This is I by 3, and this too is I by 3. So at the point A, this is what has happened. So this is your second, and this is your third. So all of them are I by 3. I by 3 and I by 3. Okay, so this is the first thing, So the moment the current, enters the point A, it splits up because it sees three identical arms, having same resistance. So it splits up into I3. Now let's talk about when the current, for example, reaches the point number C. Okay. Now I by 3 is coming here. I by 3. Now this current has two options, Either it can go here and it can go here. Again by symmetry, here the current that enters is I by 6 and again I by 6, okay? And the current, which is moving here, you know, like this, is I by 3 again has two choices that, it becomes I by 6 and this also becomes I by 6, okay? So I by 3, is I by 6 plus I by 6. So let's, concentrate on another point, which is this. So you can see on this point you have, one I by 6 and then you have one I by 6 and let's talk about this point where the current now aggregates. So apply the Kirchhoff's current law at this point and you can find the current here, which is going to be I by 6 plus I by 6 is equal to I by 3. So the current in this arm, which is, for example, DB, the arm DB, the current in arm DB, IDB is this, okay? This is I by 3. I hope this is clear in your mind. So far, so good. Now, what is our ultimate goal? Our ultimate goal is to find resistance, which is, the equivalent resistance between point A and B. So we want to find out the equivalent resistance between point A and B. And we did a small exercise of splitting the current, so on and so forth. So let's concentrate on, this branch, for example, and see what happens. So I'm just going to, so this is branch 1, this is branch 2, and this is branch 3. So 1, this is second, and this is third, okay? What we're trying to do is find the potential difference between V, A, B. And the potential difference between VAB is the sum of potential across first branch plus potential across second branch and the potential across the third branch. So if you add these, and you can apply Ohm's law now. So the current here is I by 3 into R plus I by 6 into R. And then you can see the third branch where the current again aggregates and becomes I by 6 into I by 3. Okay, so this is take an LCM of 6. So this is 3 2R plus R plus 2R. And this is equal to, broadly equal to, comes out to be 5R by 6. So the potential difference between A and B, is 5R by 6. Okay, and the current, which is entering the point A, is leaving, the point B. So the current which is starting from, this is the place where the current starts, I, and the same current actually leaves this, okay? So we know the total current in the circuit, which we are, actually referring to between A and B, because the all these branches, they will aggregate the current, this branch and this branch and all these three. So these all will, again show symmetry. So this will be I by 3 and this will also be I by 3. And, everything will get aggregated here and you again get a current I back, and which is where you started. So these two are identical. So which means the current between the point AB is I. And now you have to find the resistance between AB, which is going to be VAB upon IAB is equal to 5R by 6 divided by IAB. And of course you can, write the voltage, which is, so I think I've forgotten to write. All right, so this is in volts. So now we have a sense of, maybe I didn't write I here. Okay, so let's put an I here, which is IAB, which is actually the current I which I was splitting. So IAB is the current which gets split, in multiple arms. So I can write an IAB here, and the IAB gets cancelled, and you get 5R by 6. So that's your, equivalent resistance that you've calculated with the help of symmetry of the circuit. So you can see it takes, substantial amount of time, and therefore, this type of numerical is taught in electrical engineering. For some reason, NCERT has put it in their book, and given you an introduction, but the way it should have been given in NCERT is some simpler symmetry questions should have been given, and instead of giving direct electrical engineering type of questions. But nonetheless, you can expect some simpler numericals in your school examination or NEET examination. But you can get some. So I hope so equivalent resistance as a topic is studied and assumed to be just series and parallel. It is, but beyond series and parallel, there is another concept which is pertaining to exploitation of symmetry of circuit, where you split the current because you are able to immediately understand that the current will flow in a particular manner. So I hope this was useful to you, and I appreciate your time. Wait for my next video. Work hard. Keep on doing conceptual grounding, which is don't try to just do numericals. Always first strengthen your logic. If you find you're not able to solve the numericals, it has probably to do with your weak logic. So work on your logic, practice hard. My best wishes are with you. Thank you very much.